In this video, we're going to talk about how to find the area of a parallelogram, given 4 points that are at the corners of the parallelogram. Now let me give you a basic idea of what we need to do. So let's say we have two vectors, vector u and vector v. These two vectors can be used to form a parallelogram. And our goal is to find the area of the parallelogram formed by the two vectors. And here's the formula that we need to use. The area is going to be the magnitude of the cross product of those two vectors. So let's use that formula in this example. But first, let's draw a generic parallelogram. So we're going to say this is point A, which is 0, 1, 3. And then we have point B, 1, 3, 5. Point C, 5, 7, 5. And finally point D, which is 4, 5, 3. So how can we use these points to find the two vectors that we need? Vectors u and v. Vector u, let's define it as starting from point A going to point B. And vector v, we're going to define it as starting from point A going to point D. So we can say that u is the same as vector AB. Now going from A to B, the x value increases by 1 as we go from 0 to 1. So that's going to be 1i. Next, if we look at the difference in the y values going from 1 to 3, that's an increase of 2. So it's going to be 2j. And then comparing the z values, 3 to 5, or 5 minus 3, that's a change of 2, so 2k. Now let's do the same for vector v, which is the same as vector AD. So going from 0 to 4, that's an increase of 4. And then 5 minus 1 is also 4. So this is going to give us 4j. And 3 minus 3 is 0. So we're going to have 0k, or you could just put nothing there. So once we have these two vectors, now we could find the cross product of vectors u and v. So what we need to do is create a 3 by 3 matrix. First, we're going to write the letters I, j, k. And the first vector that we have is vector u, because the order matters. The cross product of u and v versus the cross product of v and u will give you different results. So you need to write the first vector in the second row. And so you need to write the coefficients, 1, 2, 2. So next to I we have 1, next to j and k we have a 2. Now let's move on to vector v. So the coefficients of vector v are 4, 4, and 0. So now let's calculate the cross product of those two vectors. So first we're going to have the symbol or the unit vector I, and I is located in the first row, first column, and this gives us a 2 by 2 matrix with the numbers 2, 2, 4, 0. And so let's write that. After that, it's going to be minus the middle unit vector j, and j is in the first row, second column, and so that leaves behind 1, 4, and 2, 0. And then it's going to be plus k. Now the unit vector k is in the first row, third column, and it leaves behind the numbers 1, 2, 4, 4. Our next step involves finding the determinant of a 2 by 2 matrix. So here is a 2 by 2 matrix, and to find the determinant, it's going to be A times D minus B times C. So in this example, it's going to be I, and then 2 times 0, which is 0, minus 2 times 4, and that's 8. And then we have minus j. 1 times 0 is 0, minus 2 times 4, which is 8. And then plus k. 1 times 4 is 4, minus 2 times 4, which is 8. So 0 minus 8, that gives us negative 8i. And then we have negative j times negative 8, so that's positive 8j. And 4 minus 8 is negative 4, so we have negative 4k. And so this is the cross product of vectors u and v. Now the last thing that we need to do is we need to calculate the magnitude of this vector. So it's going to be the square root of negative 8 squared plus 8 squared plus negative 4 squared. Now 8 squared is 64 and 4 squared is 16. So 64 plus 64, that's 128, plus 16, that's 144. And so the square root of 144 gives us a nice number, which is 12. So this is the area of the parallelogram. That's the answer.